Hello, what's Max heute? Today I'm going to talk about deep learning first. Deep learning, if we want to do simple, very simple, if we want to learn very simple learn model, we have to define model architecture, loss function optimization algorithm to adjust weight and so on. Important thing is, when we think about linear regression, there will be y equals to 0 to m, EIXI. Even in this picture, there is like, mm, there's EI square. In this case, if m is 0, then it will be beta 0, and if m is 1, it will be, if m is 1, if m equals to 1, then it will be y equals to beta 0 plus beta 1 x. In this case, m is hyperparameter, and parameter will be decided by training, because in linear regression, there is, in this case, there is closed form solution and matrix way, or how they create OLS. But if not, there will be, you should use the iterative uh, linear regression. Hyperparameter M is that we are deciding. This is actually related with training set and validation set. In training set, each of the hyperparameter situation, we will use different, distinct training process. In that case, there will be a lot of models. We will validate those model with validation data set. So we will choose the hyperparameter. That is how it works. And for each task, what representation we are going to use is important thing, because let's say image data, then there is such as this kind of images. There is this kind of images. Then what you should decide is uh, what is the good representation what is a good representation to find this image. And this is also same in each of the task classification tests or whatever. How can we actually represent it? This is the important issue. Um, how can I back propagation here? We will talk about back propagation in next uh, time, but the question is simple. If there's losses, then by calculating the loss, then how does this color is affected to each of the previous layers? Loss functions input will be in supervised learning prediction y and target value y. What I'm curious is what will be in unsupervised LLM task or reinforced learning. In LLM task, there is if it is GPT, then there will be real value digit output. Then you should convert it and compare it. And what they are doing is basically next token. Reinforced learning, there's like you give reward. I want to give detail in here. And if there's no closed form solution, you can use interpret bisection or Newton's or secant or so on. Yeah. Loss function optimizer evaluation metric data feeding pipeline is how we will do it in PyTorch. And PyTorch and NumPy is actually very similar if you see it here. And then, yeah, usually images are three-dimensional. Uh, if it is two-dimensional array, we call whole dimension as tensor dimension, and each of element, how many of the vector, each of vector has their own dimension. If they have 5 elements, then it is 5 dimension. And linear regression in Hardcode MLDL way, I write it down uh, because Hardcode and MLDL's difference is it has fixed feature. ML has fixed feature, and DL don't have fixed feature. So in classification task and in regression task, I want to see how it goes, and I also want to see in unsupervised learning way. Yeah. My next thing, what I want to do in PyTorch is this is the result. One result we can see here. I want to make adjust this function, and I want to adjust this function see to see the whole result in this for loop. Let me give me the time just for a second. Yeah. Uh, PyTorch, if you see here, already MNIST is so famous. MNIST is basically making classification. It's classification test for 10 classifier. Yeah, you can actually see type, train data, train images, and if you see the train images, 10, yeah, specific one train image, then there's a 28 by 28. And yeah, and you can forward it. Yeah, you instantiate the model here, and this is how we change it to the tensor. Mm, and we will iterating and evaluation that there will be output value come out, and we can use softmax and yeah, array first dimension tensor and 5-dimensional vector, and we can visualize it. It's of the train image with train label together, and we are cropping it, slicing by slicing. We can see, and batch is yeah, if we you can get the mini batch 16 or 32 or so on. So how many pictures put it together? A real world example, if you see this is 3D time series, and this is 4D image data. Mm. And we'll see the dots file again. Uh, so this is a very basic, and one another thing I'm a bit curious right now is it's actually one neural network is very similar with mm, binary classification of logistic regression, but what professor said is basically the concept or what they want to do is actually different. So I want to go to that part more deeper. And thank you very much today.